You are currently the only person in this conference.
Students, I'm just waiting for the other students to join them. Students, am I audible? Students, am I audible? Hello, students, am I audible? Students, am I audible? Am I audible, sir? Am I audible? Okay. I'll wait for another 1 minute, Amma, and I will start. Sir, actually, there are some more topics in RCP, but today I want to start the most important topic, pre-stressed concrete. Okay. I'll be telling those topics also, don't worry. But I'll be taking today pre-stressed concrete. Yes, yes. Yes, Rohit. Okay, sir. Let me start the topic. The today's topic, which I want to discuss, is the like pre-stressed concrete, or you can write fundamentals of fundamentals of fundamentals of pre-stressed concrete, or you can write fundamentals of pre-stressed concrete, or fundamentals of pre-stressed concrete. Sir, what is pre-stressed concrete is? If anyone asks you what is pre-stressed concrete is, suppose here, if I see if this is a pre-stressed concrete, if I take this is the pre-stressed concrete, internal stresses, internal stresses are introduced into this pre-stressed concrete intentionally. You will introduce the stresses intentionally so that the stresses when the are developed, when load is applied, will be counterattacked. Are you getting me, sir? Suppose you know Usain Bolt is running 100 meters in how much time, sir? In how much time he'll be running? In maximum in 9.8 seconds or 9.5 seconds. Initially, he might be running for 15 seconds, but when he has done that practice, he will be able to achieve his goal. Similarly, to achieve 9.8 seconds, he has inbuilt some means he has inbuilt that functionality. Similarly, in pre-stressor concrete, either we introduce ducts, means either you will introduce tension to the steel before or after. That is the thing you have to understand. Are you clear, students? So, what is pre-stressor concrete is pre-stressor concrete. PSC means pre-stressor concrete. Pre-stressor concrete is basically a concrete. Pre-stressor concrete is basically a concrete. Pre-stressor concrete is basically a concrete in which pre-stressor concrete is basically a concrete in which internal stresses of in which internal stresses of in which internal stresses of suitable magnitude in which internal stresses of suitable magnitude are intentionally introduced. Suitable magnitude are intentionally introduced or intentionally introduced intentionally introduced. Pre-stressed concrete is basically a concrete in which internal stresses of suitable magnitude are intentionally introduced to construct to counter the stresses to counter the stresses to counter the stresses due to external loads to a desired extent up to a desired extent. So is this clear, my dear students? So what I would like to tell you is pre-stressed concrete is basically a concrete in which internal stresses of suitable magnitude are intentionally introduced to counter the stresses due to external load up to a desired extent. Okay. Suppose see students, in RCC steel plays a passive role, but in pre-stressed concrete now immediately you will ask me. First of all, we'll discuss what are the advantages of what are the advantages of what are the advantages of pre-stressed concrete. First of all, we'll discuss what are the advantages of pre-stressed concrete. What are the advantages of pre-stressed concrete, sir? What are the advantages of pre-stressed concrete? The first advantage of pre-stressed concrete is cross section is more efficiently used. Cross section is more efficiently used. Cross section is more efficiently used. Cross section is more efficiently used in fully. Cross section is more efficiently used in fully pre-stressed members. Cross section is fully used. Cross section is more efficiently used in fully pre-stressor members. I'll tell you how it is. Suppose you want to go in a bridge. What's up? The length of the bridge is fixed. So in this, the gutter, whatever the length, you stick to that length only. So that is the reason he's telling whatever the cross section is there, the cross section is more efficiently here. Here you are telling that cross section is most efficiently used. So once the see, suppose if you want, see, this is what you have to provide. But instead of this, if you provide up to this, then what will happen? Obviously, load will increase. So when you are using efficient section means dead loads will also be reduced considerably. When you are using efficient section means dead load will be also reduced successfully. So here you can write dead loads are dead loads are reduced dead loads are reduced considerably. Dead loads are reduced considerably. Okay. Pre-stressor concrete is more resistant to impact load. It is more resistant to pre-stressor concrete is more resistant to impact and more resistant to impact and vibrational loading. Pre-stressor concrete is more resistant to impact and vibrational loading. Okay. Pre-stressor concrete is more. What is impact loading is a load falling from a height. What is impact loading, sir? A load which is falling from a height. That is called impact loading. Vibration loading means, you see here a vibration loading. What do you mean by vibration loading? When a structure is subjected to earthquake load or any earthquake, then it will be subjected to vibration loading. So here, pre-stressor concrete is more resistant to impact and vibration loading. Next, pre-stressor concrete offers. Next one is pre-stress concrete offers more resistance to fatigue. Pre-stress concrete offers more resistance to fatigue. More resistance to fatigue. Now you can ask me what is fatigue? What is meant by fatigue, sir? Fatigue is nothing but cyclic loading. What is fatigue, sir? Fatigue is nothing but cyclic loading. Or you can say, repeated loading. Or you can say what, sir? Repeated. Fatigue is known as cyclic loading or repeated loading. So pre-stressor concrete offers more resistance to fatigue or repeated loading. Sir, in case of cyclic or repeated loading means you can say when you are subjected to any generator, if there is a generator in a cellar, then it is called repeated loading. Any machine loading can be a repeated loading. Any machine loading is nothing but a repeat loading. Clear, students? Is it clear, Amma? Next one is Pre-stressed concrete is more predictable, means when it is going to fail or any sign of failure, pre-stressed concrete is more predictable. Pre-stressed concrete is more predictable compared to pre-stressed concrete is more predictable compared to RCC. Pre-stressed concrete is more predictable compared to what, sir? Compared to reinforced cement concrete. And remember, students, pre-stressed concrete is most effective in water retaining structures. Pre-stressed concrete is more effective. Water retaining structure means hydraulic dams, or you can say circular water tank, or you can say any hydraulic structures. Pre-stress concrete is more effective. Pre-stressed concrete is more effective for pre-stressed concrete is more effective for water retaining structures. Pre-stressed concrete is more effective for water retaining structures. And remember here, deflections are less. Here you can write that it is more effective for water retaining structures, and deflections are less in pre-stressed concrete. Deflections are less in pre-stressed concrete. Deflections are less in pre-stressed concrete. Hence, hence more stiffer. Hence more stiffer. So, what are the advantages of pre-stressed concrete? Is cross section is most efficiently used. Dead loads are reduced considerably. It offers more resistance to impact and vibration loading. Pre-stressed concrete has more resistance to fatigue loading. Pre-stressed concrete is more predictable compared to RCC. And pre-stressed concrete is more effective for water retaining structures. And deflections are less in pre-stressed concrete. Okay. Now, what are the materials used in pre-stressed concrete? What are the materials used in pre-stressed concrete? Sir, see, the materials used in pre-stressed concrete is the materials used in pre-stressed concrete. The materials used in pre-stressed concrete is the minimum grade of concrete. What, students? The minimum grade of concrete. The minimum grade of concrete. The minimum grade of concrete for pre-tensioning. The minimum grade of concrete for pre-tension is M40. Very, very important, sir. You can write. And for post tension it is when in post tension it is in post tension it is M30 only. In post tension, how much, sir? It is M30. So here I can say minimum grade of concrete here is for pre-tensioning is how much, sir? The minimum grade of concrete for pre-tension is M40 and for post-tension is M30. Sir, why it is more in Why it is more in post tension and why it is less in pre-tension, I'll explain you while I'm explaining the procedure of pre-tensioning. Okay, students? For now, just remember the minimum grade of concrete for pre-tensioning is M40 and for post tension is M30. Okay, next. The next one we have is the maximum cement content. The maximum cement content. The maximum cement content is not more than 530 kg per meter cube. 530 kg per meter. Suppose if you take in RCCM, this value is 450 kg per meter cube. Okay. So actually this maximum cement content depends upon exposure conditions as well as the water cement ratios. Okay. Now see students, in pre-stressed concrete, we use high strength steel. In pre-stressed concrete, sir, we use high strength steel. So let us see how this steel is used and what are the properties of the steel. Sir, how this steel is used is, suppose this steel is used in the form of, if you see olden days, a cable wire. Means if you are watching any digital TV, we used to have a cable TV. Or if you see telephone connection, if you cut the wire, it used to have wires like this. How the high strength steel is used is, it is used in the form of wires or cables. High strength steel is used in the form of high strength steel is used in the form of high strength steel is used in the form of wires. High strength steel is used in the form of wires or cables or bars. How the high strength steel is used? Either it is used in the form of wires, cables, or bars. Now, see, students, generally, 2 to 5 dia bars are used. Generally, if you see 2 to 5 dia wires are used. Generally, 2 to 5 dia wires are used. Now, see, in pre-stressed concrete, bars of 10 to bars of 10 to 32 are used. Bars of 10 to 32 are used. If you consider for wires, if you consider for wires, if you consider for wires, the Young's modulus of steel is the Young's modulus of steel is 210 MPa. The Young's modulus of steel is 210 MPa. And the percentage of elongation is percentage of elongation is 2.5 to 4%. This is for wires. The same thing if you see here for cables, not cables, for bars we can see. For bars, if I consider for bars, the Young's modulus of steel for bars is 200 MPa, and percentage of elongation is 10%. Percentage of elongation is how much? Percentage of elongation is 10%. Now in steel, what are the different compositions we have is, in steel, what are the different compositions we have is, first one is carbon. So what does or how much it should contain is, usually carbon should contain 0.7 to 0.8%. How much carbon should contain? It should contain 0.7 to 0.8%, and this will impart strength to steel. This will impart strength to this will impart strength to steel. This will impart strength to steel. If I compare manganese here, if I compare manganese here, if I compare manganese here, and manganese should be, it should be around 0.6 percentile. And what does, they can ask you, sir, what does carbon is property will do in steel? The manganese, carbon will create impact strength to the strength to steel. Carbon will create, that is the reason, sir, as carbon content increases, strength increases for a steel, but at the same time, ductility decreases. And that is one of the bad sign. Okay. Similarly, here, manganese is 0.6 percentile. This imparts, this manganese will create, this imparts toughness to steel. This manganese will create toughness to steel. Next, silica 0.1 percentile. Silica 0.1 percentile. This will act as a flux. This silica will act as a silica 0.1 percentile, and this will act as a flux. And if I consider here sulfur, if I consider sulfur here, it will be 0.05 percentile, and excess of sulfur will cause, see students, if excess of, what does if excess of sulfur will do? Sir, excess of sulfur will cause corrosion. Excess of sulfur will cause excess of sulfur will cause what, sir? Corrosion. So here what does carbon will do is, carbon will impart strength to steel. Manganese imparts toughness to steel. Silica acts as a flux, and excess sulfur causes corrosion. Excess sulfur causes corrosion. Now, what is the necessity of, you can ask me, what is the necessity of, what is the what is the necessity of using, what is the necessity of using, what is the necessity of using high strength steel and high strength concrete? Any idea, students? What is the necessity of using high strength steel and high strength concrete in pre-stressed concrete? Why the necessity of high strength steel and concrete? Can anyone tell me what is the reason, sir? Why they are using high strength steel and high strength concrete? What is the? It provides high bond stress. Okay, still. Okay, sir. Sir, I'll tell you. Suppose, see, I'll tell you a small example. If you are using a mild steel, what is the mild steel strength? Mild steel will be 250 Newton per mm square. Actually, if mild steel is used, what will be the strength actually used in prestress is 140. Means almost 50% of the stress is lost due to there are various losses. Okay, but actually in prestressor concrete, the initial stresses should be very high. That should be around 1200 to 2000. And these initial stresses high will be possible only with high strength steel. Are you getting, my dear students? If suppose if you have used a mild steel, if you have used the working, whatever the working stress is 140, but actually you have to generate a initial stress of 1200 to 2000 or 2350, and that cannot be possible with the ordinary mild steel. So that is the reason you will be going with high strength steel. Clear, students? See here, I'll explain. The question, I'll explain you. What is the necessity of high strength steel and concrete? So here, if mild steel is used, you can write here. If mild steel is used, suppose if mild steel is used, as I told you, working stress in it will be the working stress in it will be, if mild steel is used, the working stress in it would be the working stress in it would be 140 Newton per mm square. If mild steel is used, the working stress is 140 Newton per mm square. Okay. Why actually the mild steel means it should be 250, but actually it is 140 Newton per mm square. Why? Why? Because Because he is if mild steel is used, the working stress is 140 Newton per mm square. Because here what I would like to tell you is high, as I told you students, initially it should have initially it should have initially it should have high stresses. Initially it should have high stresses. How much the initial high stresses it should be? It should be around 1200. It should be high 1200 to 2350 Newton per mm square. Here it should be how much, sir? 1200 to 2350 Newton per mm square. So this 1200 to 2350 Newton per mm square can be achieved only through, sir, are you getting me? Initially the high stresses should be around 1200 to 2350 Newton per mm square. How this can be achieved? How this can be achieved? How this can be achieved? How this can be achieved is this can be achieved only by this can be achieved only by high strength steel. This can be achieved only by high strength steel. This can be achieved only by high strength steel. Okay. Students, just go through this. I'll be back in 5 minutes. Amma. Students, sorry for the delay. Is it clear, Amma? Now, why we are using high strength concrete? Why we are using high strength concrete? Why we are using high strength concrete? Sir, see, why we are using high strength concrete is why we are using high strength concrete is it offers it offers high resistance to why we are using high strength concrete is it offers high resistance to shear, bond, bond, and tension. Or you can say tension shear. It resistance offers to tension shear. Now see sir, actually if you use low strength concrete, there will be losses. There will be a loss due to elastic deformation of concrete. There will be a loss due to elastic deformation of concrete. There will be a loss due to elastic deformation of concrete. Sir, I will be discussing you the elastic deformation of concrete. Losses separately. Losses are separate chapter we are having. There can be a loss due to elastic deformation, shrinkage, or creep. Okay, that is the reason we are using high strength concrete. That is the reason we are using high strength concrete. Why we are using high strength concrete is there is a loss due to elastic deformation, shrinkage, or due to creep. Now see students, we have different methods of pre-stressing. What are the methods of pre-stressing? Can anyone tell me? What are the methods of pre-stressing? Can anyone tell me? We have different methods of pre-stressing. What are the different methods of pre-stressing? The different methods of pre-stressing are one is pre-tensioning, another one is post-tensioning. There are different methods of pre-stressing. One is pre-tensioning, other one is post-tensioning. What you will do in pre-tensioning and what you will do in post-tensioning. Sir, see, in pre-tension, I'll tell you. We'll discuss individually about the pre-tensioning and post-tensioning. Okay, what do you mean by pre-tensioning here? Sir, in the name itself, it is pre-tension. So, what do you mean by pre-tensioning or pre-tension? Pre means what, sir? Tendons are, suppose if I take, see students, if I take here, see students, if I take here, if this is a tendon, if you consider this is a tendon, these tendons are tensioned. First, this wire is tensioned, and after that, what you will do is you will do the casting of concrete. So, pre means before. So, here you can write tendons are tensioned, tendons are tensioned, tendons are tensioned Before casting of concrete, tendons are tensioned. Before casting of concrete. Now see students, how this tension is applied. This tension is applied by hydraulic jacks or anything. Here you can write tension is applied by what, sir? Tension is applied by 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 what? Hydraulic jobs. Tension is applied by hydraulic jobs. Clear, sir? How the tension is applied? The tension is applied by hydraulic jacks. Now, see, students, immediately Rohit will ask me, sir, where do you use this or how this is used? Suppose, see, students, how the stresses in steel and concrete are transferred. How the stresses. Sir, remember here, bond is the main factor. You can write here. Bond is the main factor. You can write here. Bond is the main factor. Bond is the main factor for transfer of stresses. For transfer of stresses. Bond is the main factor for transfer of stresses from steel to bond is the main factor of stresses from steel to concrete. Steel to. Now see students, you can write here long line process, or Hoyer's method. You can write long line process or Hoyer's method. Long line process or Hoyer's method is useful for long line process or Hoyer's method is useful for long line process or Hoyer's method is useful for mass production of or mass means mass or bulk production or huge in number. Now how this immediately will ask me, sir, what is long tendons kya hai, sir? Very good. Very good, sir. What is a tendon is a group of wires tied together. What is a tendon, sir? If anyone asks me, what is a tendon is a group of wires tied together. A tendon is nothing but a group of wires. A tendon is nothing but a group of wires tied together. A group of wires tied together is nothing but a tendon. A group of wires. Are Vijay? So here, what is a long line process here is, it is useful for mass production. Now see here, I'll tell you. Suppose see student, if we have a steel wire, okay, this steel wire will be tensioned with a hydraulic jar. Now see students, you will do casting of concrete and you will break it here. This is one concrete block. Okay, and again you will do casting of another thing and you will do breaking. So you'll do another casting like this, another casting of concrete like this. So that is the reason this, what is the application is, what is the application if you talk about the pre-tension concrete is, the applications for pre-tension concrete is, it is useful for, it is useful for small spans, application of, it is useful for small spans, it is useful for small spans and also for railway sleepers. And it is useful for railway sleepers. It is useful for railway sleepers. So what are the applications here is, they are useful for small spans and railway sleepers. So here please understand the students, what do you mean by pre-tensioning is, tendons are tensioned before casting of concrete. Tension is applied by hydraulic jacks. Bond is the main factor for transfer of stresses in steel. Students, they can ask you which of the following method is a method of pre-tensioning. Okay, which of the following? So here you can write Longline process or Hoyer's method is the process of. Now, where does you use this pre-tensioning? You will use for small plants as well as railway sleepers. Do you know what are railway sleepers? This is a railway track, Amma. In railway track, you will find these kind of things, right? Concrete blocks. These concrete blocks are nothing but what, students? These concrete blocks are nothing but the railway sleepers. Clear? Any doubts in these, students? Next one we will going to discuss is the post. Next one we would like to discuss is the post tensioning system. Next one we would like to discuss here is the post tensioning system. Now what we are having is post tensioning systems is here. See, students, what actually is post tensioning? I'll tell you. Suppose if I consider this as a gutter, if I consider this as a gutter, Amma, in this gutter you will have ducts. So here in the post tensioning, you will have ducts. In these ducts, what you will do is you will introduce the steel bar, okay, and you will tension these steel bars. After tensioning this, the space between them is grouted. The space between them is grouted like this. Are you getting, my dear students? Now see, students, here you can say tendons are tension, tendons are tensioned, tendons are tensioned after introducing into the ducts. Tendons are tensioned after introducing into the duct. Tendons are introduced into the duct and after that they will be tensioned. Tendons are tensioned after introducing into the, okay. Now see, students, you can see how this transfer of stresses will happen. If you have another gutter here, like this, there will be another duct here and there will be, so they are connected by end bearing. See here, students, I told you bond is the main factor for transfer of stresses, right? Similarly here, if you have two pipes, you have two pipes like this, how they are connected? They, clamp, right? Like this. So here end bearing is the, here you can write end bearing is the, end bearing is the main factor, end bearing is the main factor, end bearing is the main factor for transfer of stresses. End bearing is the main factor for transfer of stresses. End bearing is the main factor for transfer of stresses. End bearing is the main factor for transfer of stresses in steel and concrete. End bearing is the main factor for transfer of stresses in steel and concrete. Clear, student? Now see, student, the space between, we call the hole as duct. The space between the duct and the tendon. The space between the space between the space between the space between the tendon, the space between the tendon and the duct, the space between the tendon and the duct, the space between the tendon and the duct is generally grouted. And here you can write which systems are used in post tension is Magnal system, or you might have heard this. There is a separate company also. It's a very multinational company in pre-stressed concrete. Fresnit system, Magnal system, or Fresnit system, all, or you can say Gifford Woodall system. Gifford. Why I'm telling the names is they can ask you students which of the following is a pre-tensioning system and which of the following is a post-tensioning system. So Magnal, Fresnel, all these are based on wedge action. Wedge means what, sir? Some weight or inclined weight. So Magnal or Fresnist or Griffith Woodall system is based on wedge action. Now immediately, and if you see there is another option, another system also. This is the most common system. Lee McEckle. Lee McEckle system. అరే, పనాడుతున్నారు తీసుకుంటారు. అలా కూర్చోచ్చు కదా. Lee McEckle system. Lee McEckle system is based on Lee McEckle system is based on nut and bolt operation. What is nut and bolt? I'll tell you. I told you now, students, to connect the two tendons, they will be doing this. See, students, if you see metro station in Hyderabad, or if you see this one or previous, Rohit, this slide, if you see metro stations in Hyderabad or Bangalore, or if you see Delhi metro station or anywhere, what they will do is they will go with this post tensioning because they are of longer spans. They are of what, sir? Longer spans.
लास्ट वाला सिस्टम जो है सर ये वेज एक्शन सिस्टम है.
What, sir?
जो लास्ट सिस्टम आपने लिखाया गिफोर्ड वुडल सिस्टम, ये वेज एक्शन सिस्टम है.
Yes, sir. What is a wedge means? It's a means, sir, to suppose to, if you see, to pull some force, you'll use some weight. So that's what he's telling wedge action means. Okay. If you see, if you have a pulley like this, if you put some stone on it to extend, that is also a kind of wedge, means a inclined weight. So see, students, if you see here, are you clear, Rohit? Lee McEckle system means a metro station or anything can be a best example. Okay. Student, are you clear? Okay.
Yes, sir.
Now see students. Now I'll ask you, now can you tell me application here is for application for post tensioning is application for post tensioning is you can write long span bridges. Application for here is you can use long span bridges. Application for here is you can use post tensioning for long span. Now I have a question for all of you students. Why we are using M40 in pre-tensioning? Now you are aware what is pre-tensioning and post-tensioning and why we are using M13 post-tension. Can you tell me, sir? Can you tell me now? Just think practically, Amma. Now I'm asking you why we are using M14 pre-tensioning and M13 post-tensioning. Anyone in the class? Okay, let me explain. See students, in pre-tensioning, first the wire is tension. Okay, first the wire is applied by hydraulic jacks. Suppose if there is any error in the wire, then what you can do, you have to increase the concrete. But suppose first in post tensioning, first the concreting is done. If anything is there problem, you can increase slighter the grade of steel. So that is one of the reason why grade of concrete is more in pre-tensioning and less in post-tensioning. Are you getting me? Sir, see, in pre-tensioning, first the steel is subjected to stresses. So after that, if there is any error, then concrete strength can be only increased. But suppose in post-tensioning, first you will do concreting. So if there is any error in concrete, you can increase in steel. So that is the reason it is lesser. Clear, students? Students, is the reason clear for everyone? Repeat, sir. Sir, I am telling you, suppose I will tell you, you have used Fe 415 grade of steel. I am talking about pre-tension. Suppose if I have tensioned the steel wires with hydraulic jacks, okay, I have tensioned the steel wire with hydraulic jacks, but the steel wire is tensioned, but you feel that the strength is slightly lesser, then what you will do? You will do concrete. You will manipulate that strength with high strength of concrete. Suppose you have used lesser grade of concrete in post tension, but you want to increase slighter strength, then use high grade of steel. Sir, in pre-tension, you cannot play with steel because it is already tension. In post-tension, you can play with steel. That is the reason it is lesser. Clear, sir? Simran Nasir, is it clear? Amma? Sir, pre-may, you cannot play with anything with the steel. That is the reason higher grade concrete. Post-may, you can play with steel. That is the reason lesser grade. Now see, sir. Sir, this is a straightaway question in one of your HPSC as well as JKSSB, sir. What is the code for pre-stressed concrete? The code used for pre-stressed concrete is IS 1343. What is the code used for pre-stressed concrete is IS 1343. పన అంటే యాక్చువల్గా పనవాడు వస్తుంది కదా, పనవాడికి అన్ని చెప్పి ఆవిడ ఏమైనా చేయించాలి అన్ని చెప్పి. So here IS code is what? 1343. So what are the specifications here is, what are the specifications for IS? What are the specifications is, you can say the code is IS 1343, right? Now what are the specifications? Sir, see students. So the minimum cover, if I talk about minimum cover, sir, why do we provide cover? Cover is provided to have proper bond between concrete and steel, and also to protect the steel from 456. Very good, sir. IS 1343, you can write 1980 also year up. Or you, some people will write RCC means IS 456 2000. Okay, that's fine. Here is fine, but this I want you to remember. Okay, if you see about the minimum cover, in pre-tension, the minimum cover is, in pre-tension, the minimum cover is 20 mm. In post-tension, if you consider the post-tension, the minimum cover is, the minimum cover is 30 mm. The minimum number is 30 mm, or dia of cable, or dia of cable, whichever is, or dia of cable, whichever is greater, whichever is greater. In pre-tension it is 20 mm, and post-tension it is 30 mm, or dia of cable, whichever is greater. Now see students, in case of aggressive environments, sir, what is aggressive environments? Sir, all these are the values in case of mild exposure. Suppose in a hot weather or anything. But in case of aggressive environments, like if there is a sea coast or marine exposure where the steel gets corroded easily, in that case, what I would like to tell you is, these values, whatever the covers are there, students, these covers will be increased by, values will be increased by 10 mm. Based on the values will be increased by, values will be increased by what, sir? 10 mm. Values
मॉडरेट
will,
एक्सपोजर के लिए सर, ये मॉडरेट एक्सपोजर,
what,
एक्सट्रीम
sir?
एक्सट्रीम एक्सपोजर के लिए सर ये.
Sir, see, what actually I'll tell you is, we have different exposures like this one. If I consider this as mild or more mild exposure, we have mild road, mild, moderate, extreme, sorry, mild, moderate, severe, extreme, very extreme. Okay, if these values are mild exposure, suppose 20 mm to 30 mm. In every case, you try to increase 10 mm, 10 mm, 10 mm like that. Okay, sir Rohit, actually these are the values as per the code. If you see in the code book, if you see in the field, they will provide 100 mm, 80 mm like that, students. Are you getting me what I'm trying to say, Rohit? So these are the codal specifications.
Yes,
That's
sir.
now. If I talk about the next one, I would like to talk about the spacing of cables. Then I would like to talk about the spacing of cables. You can talk about spacing of cables or bars. Spacing of cables or bar. When I talk about spacing of cables or bars, if I talk in case of, if I talk in case of single wires, what should be the spacing in case of single wires? In case of single wires, what should be the spacing is, it should not be greater than, it should not be greater than 3 times the dia of wire. It should not be greater than 3 times the dia of wire, or it should not be greater than 1.5 times the maximum size of, or it should not be greater than the 1.5 times the maximum size of aggregate. It should not be more than 1.5 size times the maximum size of aggregate. So here it should be lesser of these two values. Okay. These are the things in case of what, sir? Single wires. If you talk in case of cables or large bars, if I talk about the cables or large bars, రాని ఆవిడతో చెప్పని చేయించుకో. In case of cables or large bars, it should not be greater than 40 mm. It should not be greater than maximum size of cable or bar. It should not be greater than maximum size of cable or bar, or it should not be greater than 5 mm plus 5 mm plus maximum size of aggregate. 5 mm plus maximum size of So here what is the spacing of cables or bars is, in case of single wires, it should not be greater than 3 times the dia of the wire. It should not be greater than 1.5 times the maximum size of aggregate. In cables or large bars, it should not be greater than 40 mm. It should not be greater than maximum size of the cable or bar, or it should not be greater than 5 mm plus maximum size of aggregate. Clear, students? These are the spacings in case of wires as well as bars. Next. If you see about the breaking of wires,
सर जो लास्ट केबल और लार्ज बार्स थे इसमें भी हम मिनिमम वाला लेंगे, लेसर वैल्यू.
should not be greater than means it should be lesser values. See, students, usually spacing means lesser value only will provide.
सर इन तीनों में से लेसर जो होगी,
What, sir? ये तीनों में क्या lesser value है वो लेके आता केबल का और दोनों का, सर. Rohit, tell me what's your doubt.
थैंक यू सर.
Next one we are having is breaking of wires. Next one we have is what, sir? Breaking of wires. Sir, see, when you are doing the tensioning operation, when you are performing the tensioning operation, there is some breaking of wires. Okay. So actually, if more wires are broken, then you have to understand that if more wires are broken, then you have to understand that what you have to understand? You have to understand that whether the wires you are using are correct or there should be some action should be taken. So see, students, here, when I talk about the breaking of wires, when you do the tensioning operation, of the wire, when you do the tensioning operation, okay, here you should write that during tensioning operation, during tensioning operation, breaking of wires during tensioning, breaking of wires during tensioning breaking of wires during tensioning, breaking of wires should not exceed 2.5 percentile of total wires. During tensioning, breaking of wires should not exceed 2.5 percentile of wires. Should not exceed what, sir? 2.5% of wires. Okay. See, students, whenever you are trying to tension the wire, actually, if suppose if you are tensioning 100 wires, suppose three wires are breaking, then you have to investigate. You should not leave like that. Is it the fault in the tensioning operation you have to observe? Or is it the fault in the steel? Or is it the fault in the grade of the steel? Like that, you have to do some investigation. So, after tensioning, you have to perform some investigation. After tensioning, you have to perform. You have to perform. You have to perform the. Have to perform. Have to perform what, sir? Investigation. So here, what is breaking of wires here, sir? Breaking of wires means what we are doing is during the tensioning operation, when you are trying to tension the wire, the breaking of wire should not exceed 2.5%. And here, what you have to do after tensioning, you have to perform, investigation. Okay, after tensioning, you have to perform investigation. If you are tensioning, after tensioning, you have to perform what's an investigation. Now, see, students, okay, these are the now when I talk about the side face reinforcement, this is about the breaking of wires. So, when I talk about the next concept is side face reinforcement. Sir, I told you, when do we go with in RCC? When do you go with side face reinforcement, Amma? When depth of the beam exceeds 750 mm, you will go with side face reinforcement. What, sir? When depth of the beam exceeds 750 mm, we will go with side face. But in case of torsion, can anyone tell me how much depth exceeds you will be providing, sir? In case of torsion, can anyone tell me? Very good. In case of torsion, it is 450 mm. So when I talk about the side face reinforcement, when depth of side face reinforcement, when depth of beam exceeds or when depth of the web exceeds 500 mm, when depth of the beam exceeds 500 mm, longitudinal reinforcement, when depth of the web exceeds 500 mm, longitudinal reinforcement is provided. How much it is 0.1 percentile of area of the web. See here, when depth of the web exceeds 500 mm, longitudinal reinforcement is provided is 0.1 percentile of area of web. And here this steel will be provided, as I told you, this steel will be provided on both the faces, on this face as well as on this face. On both the sides it will be provided. Or you can say, in this case, the spacing between them should not exceed 200 mm. Here, spacing between these bars, these spacing should not exceed 250. This should not exceed what, sir? 250 mm. Any doubts in this, students? Any doubts in this? If you have any doubts now, you can ask me, sir. Sir, notes I will send you today. Okay, actually yesterday I forgot. Amma. Any doubts, you can ask me, sir, now. Sir, any doubts? Explain aggressive. What? Imran Loni, I didn't get you. Aggressive spacing. Okay. Sir, okay. See, student, what you are trying to. Sir, aggressive environments means suppose in a sea coast, there is a sea coast. Sir, the breeze will be having alkali nature, or you can say salty nature. Due to this salty nature, the steel gets corroded easily. So this will be considered as extreme exposure, or you can say very severe, very extreme exposure. Okay, in this case, whatever the suppose if you are using 20 mm cover, minimum cover, in this case you will use some 40 or 50 mm because it's a severe exposure. Or if you are trying to store, if you are trying to store a oil in a tank, this oil can react with the cement. So here also you will provide more cover with pozzolana cement. So this is what I want. And here, whatever the spacing, here if I talk about the spacing in side face reinforcement, you will be providing the steel bars, right? The steel bar spacing should not exceed 200 mm. Usually it should not exceed 300. But in case of side face reinforcement, it should not exceed 200 itself. That's what I want to tell you. Imran Loni, did I answer your question, sir? Did I answer your question? Okay, I'll be sharing you. Okay, and one more thing, students, not only RCC, sir, तीन classes है. Sir, not only RCC or soil or anything, don't try to read extraordinary syllabus. Sir, you are preparing for JE and AE and you cannot read for ESC. And see, you have to learn the subject up to the point by point. Here in AE and JE, more questions are of memory based. In ESC, IES, or in GATE, you'll get lot of technical questions which are of problematic. Okay, so that's how the preparation should be there, sir. If you are preparing for JE and AE and taking classes for GATE and ESC, it does not work for you, sir. That is the reason I will change my subject style delivery according to your classes. And this will be understand only once you write the exam. Okay. Thank you. We'll see you tomorrow. Bye bye. I'll send you the notes, everything today, sir. Thank you, everyone.